All right, today for Algebra 2, we are doing section 6.3, which is zeros and inequalities. So our objectives, first, are to determine the real zeros and y-intercept of a quadratic function. 2, use the graph of a quadratic function to solve quadratic equations and inequalities in one variable. And 3, we're going to graph some quadratic inequalities in two variables. All right, so I'm tripping over my tongue a lot already. Hopefully that stops soon. So first up, let's start with the definition. Okay, so we have this zero or root. Those are the same things. Okay, so you might give yourself, like, box that in or something. A zero or a root of a function, okay, is the value of x for which f of x equals 0. Remember that f of x is the same thing as y. So it's the value of x for which y equals 0, okay, if we're putting that in. It's a function's real number zeros are the x-coordinates of the graph's x-intercept. Okay, so the zeros or the roots of a function are the x-intercept, because we're going to have, if the 0 is 6, then it would be 6, 0. Okay, it's the x-coordinate of that we're going to look at. So that's what this next little section is about here. We've got our y-intercept is 0, comma, our c value in our equation. So the x-coordinate here is 0, which we see right there. The y-coordinate is our f of 0, because if we put 0 in for x, we're going to get out c. So if you think about that, like, this is therefore, if we did f of 0, which means we put 0 in for x, in our equation we would have a times 0 squared plus b times 0 plus c. Well, a times 0 squared is just 0, plus b times 0 is going to be 0, and then it leaves us with the c. So our f of 0 is c, which means our y-intercept is, again, 0, and whatever our constant is, whatever that number is, our y-intercept. Now, our x-intercept, or our zeros, okay, is what we're talking about today. So the f, it's the x-coordinate. So here, f of x equals 0. So it's when everything on the right equals 0 is going to be our x-intercept. So we have to write the equation. We have this x-coordinate, so our f of x, or our function, equals 0. So we're going to write our whole function and set it equal to 0, and then solve. So maybe you want to write in there, set function equal to 0, and solve. That's what that really means. And in this case, our y-coordinate is going to be 0, because right here, right, f of x, or our y-coordinate, equals 0. So we've kind of already been doing this a little bit. When we look at it, you're going to be like, oh, I feel like we've been doing this, because we kind of have. All right, so let's look. We've got some things kind of crammed in here. I was trying to get it on one sheet front and back and didn't quite make it. But anyway, so let's look at example 1. It says identify the following. So the first thing we want is our y-intercept. Where does this graph cross the y-axis? Okay, well, it crosses the y-axis right here. So what position is that? Okay, well, it's going to be 0, comma, 1, 2, 3. So 0, negative 3 is our y-intercept. Okay. Then we want our x-intercept. Well, notice it crosses the x-axis in two places. So we want both of those. All right, so the first one is 2, 0. And the second one is 4, 0. All right, so then the next question says, the function's zeros. When it's asking for the zeros, we just write the x-coordinate of the x-intercept. So we would say 2 and 4 are the zeros. All right. So example 2, or example 1, okay, we did it graphically. We were able to look at the graph of it and find our zeros and the intercepts. In example 2, we want to find the intercept and the zeros, but we want to find it algebraically this time. Okay, and it says, hint, evaluate when x equals 0 and when f of x equals 0. That's what we just talked about up above in the notes, what each of those means. So in the first one, okay, I've worked it, started it out a little bit. So here's our function. R of x equals 1/2 x squared plus 2x plus 2. So our hint said evaluate when x equals 0. Well, that's what I did. I put r of 0 equals 1/2 of 0 squared plus 2 times 0 plus 2. So if I solve this, 1/2 of 0 squared is 0, plus 2 times 0 is 0, plus 2. So my r of 0 equals 2. So my y-intercept is what? Excellent. All right, it'd be 0 because that was my x value, and 2. All right, for the next one, I'm going to evaluate when f of x equals 0. So in this case, I wrote my function. It's actually r of x, not f of x. So r of x equals the 1/2 x squared plus 2x plus 2 equals 0. Okay, notice this time, so I'm really looking at this part. I set my equation equal to 0. All right. So with that being said, now I need to do some work. Okay, so if you recall, we always want to look for the GCF first. So I converted this 1. Okay, I had a half, so I multiplied everything by 2 to get rid of my fraction. So that's where this equation came from. All right, was that I multiplied by 2. So I didn't have a fraction. Now, our first goal is always to multiply by the GCF. So we have a 2, a 4, and a 4, so I'm going to factor out a 2. So it's going to leave me x squared plus 2x plus 2 equals 0. Wait a minute. No. Let me go back. 1/2 times 2 would not give me 2, would it? No, it wouldn't. It would just give me x squared. So cross out that 2. We should have x squared plus 4x plus 4. That makes more sense. All right. And now, with that being the case, I can actually see that this one, we need to factor it. Okay. So it doesn't have an a term. There's a couple ways you can look at this, but because you could do completing the square, or you could do the quadratic, or you could just factor it out. Okay, you could see that this is a special one because 4 is a square number, but we're going to factor it. Okay, so what are the factors of 4 that add to be 4? Well, 2, right? 2 times 2 is 4. So this is the quantity x plus 2 times the quantity x plus 2 equals 0. All right, so we're going to say, well, x plus 2 equals 0. So subtract 2. So x equals -2. And I would do the same thing with this one. Now, do I need to because they're identical? No, but typically, right, when they're not the same, I would have to solve each of these for 0. But they're both the same. So here, my 0 is -2. And we might say -2 equals x even if we put it into an equation form. But there's my 0. I can also get the x-intercept from that. So it says right here, right? The x-intercepts are zeros. I lined it up perfectly. I was just standing and my shadow was blocking it as I was recording. Okay, now the cool thing about this, I'm going to point out, is that this is called a double root right here. Okay, it's when there are two factors that produce the same root. So this is a double root because we had x equals -2 and x equals -2. So that's the other reason I wanted to work it out. So you could see that both of the factors were going to produce the same root, the -2. So that's called a double root. Kind of cool. All right. In example 3, it says find the zeros of each function, approximate the irrational roots to the nearest hundredth. Here's our hint. Set the function equal to 0 and solve. All right, so A, I've kind of already started a little bit for us. Okay, so I took the function and I set it equal to 0. That's really the only part that I did to get us started. All right, so then we are ready to solve. Well, first up, we see this negative on the outside. We need to get rid of that before we can do the square root because we have the exponent of 2. So we need to divide by -1. Oh, actually, I lied. Getting ahead of myself. I thought my equal sign. Let me pay attention. I need to move my 6 first. Then I can divide. Okay, so I'm going to have negative times the square quantity x plus 2 squared equals -6. Then I can divide by my -1. Okay, so then I have the quantity x plus 2 squared equals a +6. That looks so much better. Now I can take the square root of this. So I'm going to have x plus 2 equals a positive or negative square root of 6. Remember, anytime we take the square root, we have to have the positive or negative option. Okay, we need to get x by itself. So we do what? Good, we subtract 2. So x is going to equal -2 plus or minus the square root of 6. All right, so that's our exact answer. But we need to get the approximation, it said, right? Approximate the irrational roots. So if you put that in your calculator, you would get out that x is approximately, so use those wavy lines for approximately, 0.45 and -4.45. That would be your final answer. Because remember, maybe we need to take a step back. This means I'm going to do -2 plus the square root of 6, and I'm going to do -2 minus the square root of 6 in my calculator to get those two separate answers. Okay. All right, so let's look at B together. We have q of x equals x squared minus 2x plus 3. So you don't have to, like the hint was really good for the first one because it had the square in it already, right? It had the quantity squared. This one doesn't, so we don't have to use that hint. We can do anything we want to solve it. So let's practice our quadratic function. All right, so we've got a is 1, b is going to be -2, and c equals 3. All right, in doing this. And let's do our quadratic. So x is going to equal -b, so -2, right? Plus or minus the square root of b squared, so -2 squared, minus 4 times a, which is 1, times c, which is 3, extend my square root sign, divided by 2 times a, which is 1. Okay, so then this is going to equal a +2 plus or minus the square root of negative 2 squared is 4 minus, okay, 4 times 1 is 4, and 4 times 3 is 12. This time I made my square root too long. And 2 times 1 is 2. All right, so let's take that a little further. That's going to give us 2 plus or minus the square root of 4 minus 12 is negative 8. All right, divided by 2. Okay, let's check that out. Some things here. We have the negative inside of our square root, which means we can take an I out, right? And we also need to look at the square root of 8. So remember, to do that, we look at 8 divided by, we do the division by of primes to see what prime numbers are in there. So 8 divided by 2 is 4. 4 divided by 2 is 2. Okay, so remember, when we have a pair of those numbers, we get to pull them out because 8 is the same thing as 2 squared times 2. Okay, so if we do the square root, then we can take that out. So this is going to equal 2 plus or minus the 2i, because we took an I out, times the square root of 2 divided by 2. Okay, we can simplify this. Remember, we can divide each of these by 2. So 2 divided by 2 is 1. So this is going to equal 1 plus or minus 2i divided by 2 just leaves us with I times the square root of 2. So our x equals 1 plus or minus I times the square root of 2. And that can't get an approximate answer. That is the answer. Okay, there is no such thing as an approximate for that. Okay. So putting into practice all those skills, and again, you can choose whichever way you want to solve these, but always look, it's kind of like substitution and elimination. Like there's a quicker strategy that you can use depending on the setup of your problem. So look for that first. This one, it already had the square in there, so the quickest way was going to be to take the square root, solve by taking roots. This one didn't have that, so we could choose. It also would have been very quick to just do factoring. What are the factors of 3? That would get you negative 2. And so you could try that way, but looking at the answer, would we have gotten that? No. So if you look at it and you're like, wait, there aren't any factors that are going to work or something, then that's okay too. So try one strategy and then maybe another, it won't work and you have to use a different one. But it's okay to make mistakes. All right, let's look at quadratic inequalities. This is just a really long problem. Okay, this is the one I couldn't get all crammed in. So quadratic inequalities. I want you to recall, right, these key points. If it's less than or greater than, we use a dashed line. If it's less than and equal to or greater than and equal to, use the solid line. Remember to shade above or below the curve. This time we're doing a curve because it's an inequality. All right, so example 5 says a graph y is less than negative x squared plus 4x minus 3. But we're actually going to graph the related function. Okay, we're going to kind of forget for a minute that it says less than when we go to solve everything and do it so that we can get the shape of the graph. And then we can come back and look. All right, so the first thing we need to do is find our y-intercept. So that is when x equals 0. Okay, so I've done that for you. I've put 0 in for x and solved and got y equals negative 3. So my y-intercept is 0, negative 3. Number 2, we want to find the zeros. So that's when f of x equals 0. Again, I've solved that, kind of done that for us. So we've set the function. Okay, we've pulled that negative x squared plus 4x minus 3, and we set it equal to 0. and then started to solve. So I divided by -1 to get rid of the negative. Now that I have this, I did the factoring method. Okay, -3 times -1 is +3. -3 plus -1 equals a -4. So then those numbers came back in there. I set each of those equal to 0. So the quantity x minus 1 equals 0. The quantity x minus 3 equals 0. And solved. So I got my zeros to be x equals 1 and x equals 3. So remember, those zeros are the same thing as my x-intercepts. All right, next up, we're going to find the vertex by completing the square to put it in vertex form. So find the vertex by putting it in vertex form. All right, this is the one that took a while. Okay, takes a little bit. Let me clear this and move it up. I don't know what just happened. Okay, Parade's got its back. All right, so I want to move this up a little bit and perhaps over. All right, so this is at step 3, finding the vertex by completing the square, putting it in vertex form. Okay, so remember, we group our first two terms together and we factor out what we can. The only thing we could factor out here was that negative, but that's okay. We're fine with that. Then we add the negative b term, or the b term, so that was -4 divided by 2 squared. We add that to our quadratic term and our linear term. Then we subtract that same thing, but it has the twist. Okay, that's why over here it says, don't forget to distribute the factored amount. All right, this negative that was factored has to come back over here. Okay, because it's going to be factored. If I look at it, it's going to be factored to this number. So I have to also factor it, like I have to make it apply to the one we're subtracting as well. Otherwise, it changes everything. And we don't want to change the equation. All right, so we subtract and distribute the b divided by 2 squared term. Okay. Now, our b divided by 2, so -4 divided by 2 is -2. -2 squared is 4. So that's where this 4 came from. And so here we have -4 divided by 2 is -2. -2 squared is 4, but we had this negative right here, so that's why there's a -4 in here. Okay, so minus the -4. Okay, this was a perfect square because this was a 4. We actually did the problem like this earlier. So we ended up with that quantity x minus 2 squared, -3 minus a -4, which is the same thing as plus a +4, is +1. That is vertex form. Okay, because remember, our vertex is the HK. So our H is 2, our K is 1. Our axis of symmetry then is 2. So step 3 probably takes the longest. Again, I know that's where we're kind of struggling, or we've been struggling, and that's the newest part. It's that completing the square and then completing the square with a twist that we've got to get in there. Okay, so go to your last page so we can graph this. Because it says use symmetry to plot more points. And then step 5 is to shade accordingly using a test point. So let's do step 4, the plotting the points. Okay, so we're going to plot the y-intercept. Remember that was here. So we're going to plot our y-intercept. Let me just transfer all that information. Okay, so on the previous page, because you've got it on the previous page, we found that the y-intercept was 0, -3. Our zeros are x equals 1 and x equals 3. Our vertex is 2, 1, if I could get that in there. And our axis of symmetry is x equals 2. All right, so let's graph these. So our y-intercept is 0, negative 3. 1, 2, 3. Our zeros are, so our x-intercepts are the same thing, are at 1 and 3. And our vertex is at 2, 1. Our axis of symmetry is at 2. All right, so it said plot some more points based on symmetry. So we've got this one. So really we could just plot this one. It's 2 over from the axis of symmetry. So we want to go 2 over and plot the next point. All right, and then we want to make that smooth curve parabola. Okay, let's do a question that wasn't asked. Yours should hit the points. It's kind of hard to do up here with my shadow in the way, but yours should land on the points, right? Where mine does not. So is this a min or a max, this vertex? Good, it's a max because it opens down. And so our range would be y such that y is less than or equal to, perfect, 1. Okay, that's just some extra. Like, we could throw all the things that we know at this problem. Okay, we don't have to, but we can. We've been doing it for a while now. Okay, last one is where do we shade? Because this is an inequality. Oh, which reminds me, I messed up because it is an inequality, right? It was y is less than negative x squared plus 4x minus 3. So let me back this train up a little bit and make these some dash lines in between here. I'll just have to take those out. Okay, so yeah, so this should be some dash lines for our inequality, or our parabola. Okay, now some test points. I went ahead and picked 0, 0 as my test point. It's always the easiest if it does not fall on your function. Okay, so I picked 0, 0, which means I'm going to plug 0 in for the y, and I'm going to plug 0 in for all my x's, and see if it comes out right. So when I do this, right, I get negative 0 squared plus 4 times 0 minus 3, I just get negative 3. So is 0 less than negative 3? No, no it is not. 0 is greater than. So since this is not true, this is false, we shade the other region. The 0, 0, our test point falls outside the parabola. So we don't shade that, we shade the region inside the parabola. Since our test point was a no, it was false, we have to shade the other region. Okay, we don't include the region where our test point falls. All right, that is it for today. So I hope that it's clear as mud. And you guys can go ahead and get started on your homework on page 251. I'll see you tomorrow.